probably not a good idea.
I'll finish up this and then I'll show you what I did.
This thing.
Yeah.
Or maybe
All I
like
need to get it off is a little angle, and
This
nobody will
one,
see it.
I mean, I've already done homework 9 and other stuff been working around.
Okay. Today I'm gonna I'm sort of retreating to a little computer science, which is more than I normally do. When they invented computer languages, there was two things they had in mind: speed. The machines weren't very fast, and the second thing was that they didn't have much memory. So what they tried to do is they tried to make the programs as short as possible so they wouldn't consume a lot of memory. And what they invented was an idea called the loop. I want to show you how the loop works, because it really doesn't, it has nothing to do with solving the problem. You can actually do everything without a loop if you want to. Loops aren't required. But if you want to do it in an efficient way, and you want to do it in a way that's easy for you to read your program and figure out what's going on, then the loop is very, very useful. So I want to talk about how it works. And to begin with, when we have a variable, normally, we say, we have a variable, and whatever it is, doesn't make any difference what it is, and we can set it equal to 0 or whatever we want. So we make up variables like that. We've been doing that right along in the class. Okay. It is possible to make a lot of variables at the same time. Instead of making one, you can make many at the same time. So for example, I could, let me just write it, then you'll see what I mean. I can say variable, my array. This is just a name, by the way. You can do any name you want, that's just a name. Equals, and then you put one of these things, it looks like that. And then supposing I want 5 numbers. Like that, 1, 2, 3, 4, 5. What I've done is I've created 5 variables at the same time. Just by doing this, I created 5 variables. And the question is, how do you get to this variable? Down in your program, when you want to add this to something, how do you do it? Or if you want to add that one, or that one, or that one. Well, the way you do it is, you actually put in the location of that number into the name. So for example, if I want to add 3 to 16, I would say, let's say a variable, this is down in the program now, x equals 3 plus, I want to add it to that number right there. Well, that number is in the 0th position of this thing. So here's what I would write. My array 0, like that. And what that 0 says is I'm talking about that element right there. That's the element of the array. If I wanted to add it to 22, I would put a 1 in here. 2031, I'd put a 2 in here. In other words, you put in the number that represents the one that you have, and that's what it does. So in other words, it discusses this right here. Depending on what that number is, we'll talk about any of these numbers that are stored in this array. And that actually is very handy for a lot of programs that you might want to do that, because you create a whole bunch of things right away. You don't have to say variable this equals that, variable this equals that, variable this equals that. You just do it in one sweep. And then you give it the names based on 0, 1, 2, 3, 4. Now notice when there's 5 elements in the array, that you only count to 4, you never count to 5, because 0 is the first one. That's its first name. So this right here, inside of these brackets is where the number goes. So if I put 4 in here, for example, and this is my array, and then when I put 4 in here, 0, 1, 2, 3, 4, I'll get 2. That's going to equal 2. Okay, does that make sense to you? So that's how you store stuff in these arrays. It's not how you use them, but that's how you store them, okay? So, the question is, once you've got them in there, you've saved a little bit of writing by saying my array, blah, 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 blah. You haven't said my array 1 equals this, my array 2 equals that, and so forth. You just created it in one blurb. The question is, how do you take advantage of that? How do you actually use it for anything? Well, what happens is, they have what they call the for next loop. That's one of the big magical things in these languages. It's called a for loop. And it works like this. Supposing I have a variable here, and supposing it's that equals this right here. This time I'm going to put it in. I'm going to put strings in it rather than numbers. Notice that in 5, 9, 3. I'm going to put actual strings in it, like I have, like a, for example, Ford, comma, a Toyota, comma, Honda, whatever, etc. What I have in here now is not 3 numbers, but I have 3 strings, 3 different strings, okay? And if I said down here, alert, if I put an alert down here, and I said, show me what's in this, show me what's in the position 2. This is 0, this is 1, this is 2. Show me what's in position 2. What I would write is trucks, oops, trucks 2. Like that. And what would come out would be Honda would come out. Does that make sense to you? So this right here is the variable name, and this is which one? This is 0, 1, 2. So 0 would be Ford, 1 would be Toyota, 2 would be Honda. So that's what comes out. Now the question is, what if you wanted to make a big list of these things? You wanted to have all of them come out one after the other. You wanted to have them come out to alert box. Okay? Here's what you could do. Make this thing called a loop, and it looks like this. For, the word for is required, variable, I equals 0. I'm going to write it and then we'll talk about it. I oh, it's me. Okay, so I is less than, in this case right here, is less than 3, and I plus plus. Now, let me just do the whole thing, and then I'll say alert trucks I, like that, and then close it. Okay, here it is. Suppose I want to list out, and I want to alert each one of the trucks. I want to see each one of the trucks that's in my array. This thing right here says, create a variable called I. We call it I. The most common ones are I, J, and K. That's because in Fortran, back in the old days, they picked those 3 letters. I don't know why. I, J, and K to be the subscripts of the variables we're going to use. These right here, I, J, and K are the common ones. You can use any word you want today. It doesn't make any difference. But I is a pretty common one. So what this thing says is start at I equals 0. Notice set I equals 0. And then keep looping through this thing as long as I is less than 3. In other words, if I gets to 3, don't do it. Do it for 0, do it 1, do it for 2, but do not do it for 3. And what happens is this right here says add 1 to I each time. So here's what happens. The first time you bump into this thing, it says I is 0, okay? And what it does is it comes down here and it prints out truck of 0, which is Ford. Then it bounces back up again. And now it adds 1 to I. I becomes 1. It just turned into 1. And then it says, is that less than 3? Yes, it is. So you go down here and you print out trucks of 1, which is Toyota. And then it bounces back up again. And now it adds 1 more to it, so an I becomes 2. It says, is I less than 3? Yes, it's still less than 3. So it comes back and prints out trucks of 2, which is that guy right here. And then it comes back up again, then it adds 1 more to I. Now I is 3. Now is I less than 3? No, it isn't, and it stops. It doesn't do it anymore. In other words, it'll only operate as long as I is less than 3. Once it reaches 3, it's no good anymore. Now the reason why they have to have this particular test right here, this is like an if statement right there. The reason why is because arrays start with position 0, which is very weird. This is position 0, position 1, position 2. So whatever you do, you don't want to get to position 3. So it says only work as long as you're as you're in the range of what's there. Because otherwise you're going to be trying to print something that isn't even in the array. It's going to be no good. So that right there is how you make a loop. This is right here how you make a loop. It starts with open brace and close brace, just like an if statement would, except you have this thing right here. This can be any letter you want, except it has to be the same as that one, the same as that one, whatever it is. This says start at 0, don't go to 3, stay below 3. And this one says every time you bounce through this thing, add 1 to I, make it 1 bigger. That's what that instruction means. And if you use like banana for the variable, banana equals 0, banana less than 3, and banana plus plus is what you have here if you use that variable rather than I. And then down here you put banana here, of course. And that's it. That's pretty much how these loops work. That's the simplest version of how they work. And I use some in today's class just to show you how they're used. And so what you gain here is if you had 300 of these things, 300 trucks up here, you'd only have to have one loop to find whatever you want in those 300 trucks, the same loop. Otherwise, you'd have to print out 300 things saying print out 300 times. This one can just do 1, and if this went to 300, if there were 300 of these things, it would go through here 300 times, and it would see every single one, but it would only have this number of code lines rather than 300 code lines, one for each one. So basically, that's the trick. That's where you gain all the advantage. Okay. So what I did online is I created some programs that use these loops, and I created one that did not use the loops. It turned out in the particular programs I wrote, it took about like almost 100 lines of code if I didn't use the loop, and about like 30-something lines of code if I did use the loop. So in other words, I shrunk them down so that the programs were much shorter. The nice thing about doing it is that, for a programmer's point of view, is if you use a loop, you only have about 6 or 7 instructions you have to look at to make sure they're right. If you make a typo, and suppose you had 200 items, you'd have to make sure that all those 200 items were correct. You have to verify they're all correct. If you only have one loop, then only the stuff in that loop has to be correct, which is just a very small, and for a programmer, that's a great advantage, because you don't have to go through all the work of debugging the thing that's very, very long. So that's the reason why people use loops. Now, there's a bunch of other things I have to talk about while we're talking about this right off the bat. It's possible to create an array that has nothing in it. These are called arrays, by the way, A-R-R-A-Y, array. They're called arrays. You can make an array that has nothing in it to start with. So you can have this. You can say a variable, new array. As I say, that's any name you want to use right there, equals, has nothing in it. But suppose you want to put something in it. You want to put something in that array. I want to put the word cat into that array, okay? Here's how you do it. You say, okay, I got this thing called new array, and what I can do is I can say new array. This is down here in the program someplace. Dot push equals the variable cat. Sorry, that's wrong. Pardon me. Cat right here. The variable cat. So in other words, whatever is in the variable cat will be pushed into that array. So if there's a 5 in cat, it will be pushed into the array. And it will end up in the first position, the 0th position. So right away, supposing cat was equals 5. Supposing it equals 5, okay? And I said push that into the array. Well, what's going to happen in the 0th position, you're going to have a 5 here as you do that. And if I did the same thing here, push, and I put dog, and supposing dog was like a different number, like equals that, then 7 would be pushed into here, and it would go right here. And every time you push, you push a new element into the array, okay? Now the question is, you might want to know, at some point you might want to know how long that array is, how many characters, how many things are in there, because otherwise, if you make a loop and you want to check to see, you don't want to go any bigger than the array is, you have to know how many things are in there. So would you say I is less than 3, or is it less than 9, or less than 7? How much is it less than when you keep pushing stuff in? How long is the array? Well, it turns out that they have this for you. This is something you're given. We'll call it new array. dot length, that's a magic word, length, equals, we'll call it x, whatever. New array dot length automatically gives you how many elements are in that array. So for example, if you said blah, blah, blah right here now, it would give you 2, because there's 2 of them in there. Okay? So it tells you, this thing here will tell you how long an array is. How long is it right now? What's the length of the thing? So you see, there's a few things involved in this thing. One is that you can create an array empty, and you can push stuff into it, and then you can check to see how long the array is, how many things have been pushed into it. Okay? I'm going to show you how to use these things. We'll use all these things in the programs, but for starting today, the easy thing I want you to do is remember is simply this, that it is possible to build an array, put stuff in it, and it's possible to make a loop to check. You can either check what's in there, or look for something in there, or print out something that's in there. In other words, you can go through that whole array and look for things if you want to. For example, supposing you want to know, let's write a quick little semi-program here. Supposing you have this array over here, and suppose it's a string array. We'll do the cat dog one again. Okay, you got cat, dog, chicken. Supposing that's your array, and that's the stuff that's in it. Cat, dog, and chicken are the 3 things that's in it, okay? So therefore this array, this is 0, this is 1, this is 2. Supposing in your program someplace, this is what you have, and now this could be, supposing you were writing for one of those colleges that doesn't like to have bad words online. They test to see if there's words like heck, darn, and gosh. If they don't allow people, it just closes them up, they aren't there. So what they do is they look to see if you have heck, darn, or gosh. They look for certain words, and if they see one of those words, they say, no, we have to do something, okay? So, what you could do is you could say, make a loop to go through all the words you have, however many they are. You can say this, for variable I equals 0, as long as I is less than. Now, at this point, we know that there's 3 things in there, right? We know that, so we can say 3. But supposing we didn't know how many were in there, but we wanted to check every single one. Supposing this thing, people have been pushing stuff into it. There's all kinds of animals in there now. It's like Noah's Ark. It's got full of stuff. And you don't know any longer if it's going to be 3 or not. So what you do is you say, well, I want to be less than new array dot length. What that does for you is that thing right there will turn into 3 because there's 3 things in there. So it's like saying I is less than 3, which would be correct. If I put 4 things in there, it would say new array is 4, so I want to check up to 4, but not up to 4, but everything below 4. So you can use that, you can put that right in there, and that will tell you how long your array is. Therefore, your loop will work correctly. It won't go beyond what you really have in there. And then finally, what you say here is I++, again, same thing as you did before. Now, suppose you want to say, is cat, dog, or chicken in there? So supposing you say, well, if whatever's in this array right here, right now, I'm going to say new array, I equals dog, then do something, return or something, do something. So here's the thing. Here's the loop. It goes from here down to here. And I starts off at 0, and it goes to 1, and it goes to 2. It never goes to 3, but it goes 0, 1, and 2. So when it comes down to 0, it says, is cat equal to dog? No, it is not. So it bounces up, adds 1 to it, comes down and it says, is dog equal to dog? Yes, it is. So it sees dog, and it returns. So in other words, what this little loop here does is it looks in the array to see if it finds a word that's in there. Is there a word in this array that I'm looking for? If it's looking for the word dog, it says, is the first one dog, the second one dog, the third one dog? Where is dog in here at all? And of course, if you don't find it at all, you'd fall through and you'd never hit it. You'd never go to whatever, to do whatever you want to do over here. Does that make sense to you? So that's what these loops are for. They're very, very handy for doing stuff like that. And so let's let me just open up some of the programs and we'll take a look at them. And I'll show you how I use these things to show you what the advantages of using them. They're not only for graphics. They're only, I'm using them for graphics because this is the kind of thing that normally in a course in computer science they would teach you like the first week or something, or the second week or something. It's very early on. That's because everything they do is involved around the logic of loops and stuff like that. We aren't doing that. What we're doing is we're actually taking advantage of sound and visual and movement and stuff like that. So we aren't doing the same thing. But this is something you'll see in programs, and if you see it, you might as well know how it works and figure out how it works. And if you ever want to use it, you can actually take any of the programs that I use it in and take advantage of it, in the same way that I do. So let me just turn the computer on here. I'm going to use this computer today to do what we got to do.
This is like the final, but it's just, it didn't show up in the puzzle when I did it. It did it first, but like, in the picture,
This is today's stuff right here.
I just use, put it into Paint or something.
I'm going to start off with the easier programs, the ones that who would give us some experience here. Let's take the photo. This is the okay. This program, not too good. Whatever. This program right here. If I hit the space bar, it gives me a picture. Let me just get this up a little bit better. I am tired of these people trying to fix things you don't want to fix. That should be visible to people at home, pretty much. Okay, so basically every time you hit the space bar, it gives you a different picture. These pictures aren't completely visible because they're bigger than the screen than I can project. But they actually, they actually show you some people in very precarious positions here up on the hills and places that I no longer want to be. I used to rock climb and I get scared of it after a while. I never did anything like that though.
Oh my gosh.
Yeah, is that scary or what?
He's not even, he's free.
And he hasn't got any rope or anything, it's just so weird. You see he's got a little pack of powder there. Yeah, that's scary stuff. But, I mean, and they get to all kinds of positions that I can't believe they actually feel like spiders or something. They come up onto it, they can like take it down. Anyway, this is just a photo album. That's all it's a photo album, okay? By the way, a lot of these people are from around here. So the thing is, if you're going to have a photo album where you just want to hit the space bar and and you have the different pictures go, you can do that as long as you use an array. You can do it very simply. It's a very easy idea. So what I'm going to do, I'll show you the program that actually uses the array. The array stores the pictures, which is very, very interesting. So let me go to, see if I can get this computer for me. No, it doesn't do that. So I got to go here. Do the program itself. There it is. Okay, to start off with, I hope this is visible to everybody. Can you read that? Everybody read that? Okay. So, here's what happens. To begin with, I took all the pictures I wanted to show in this program, and I created an array called pictures. See, it's pictures right there. It equals, the only reason why this goes down the line is because there wasn't enough room and it automatically line fed. And notice it starts off with one of these open brackets right here. So the bracket starts, and then I put quote, climb0.jpg, unquote. That's actually the name of the picture in my file folder. That's the source. That's the source of the picture. And then I have another one I call climb1, and climb2, and climb3. In other words, these right here are the names, the actual names of the pictures in my file. It goes up here, it goes all the way down to climb I just went into letters after I get out of numbers. And that's all of them right there. It's like, I think it's like 20 of them or 19 of them or something like that. So there's quite a few. So basically, I would have had to bring all those pictures in manually, but I didn't do that. I just simply wrote them into this array. Now, they aren't on my computer yet, but they're actually, the names of them are in my computer, and that's what counts. And then what I do, let's get down to the program, how the program actually works down here. And as you can see, the body starts on load, and it hits startup right away because I'm using the keyboard to, I'm hitting the space bar to change pictures. So therefore I'm using the keyboard, therefore I have to activate my mouse key right here. You can't see it, and the mouse key has to be activated right here. Okay? So then, down at the bottom again, down at the bottom of the page again, so you start off, you say startup, and then I gave it a style, put everything in the middle. It's going to be a picture, so I said put it all in the middle. Then I put a title on it, said no fear, you put anything you want there. And this right here is the very first picture. The very first picture is just the one that says, it says to you, this is a mountain climbing thing, hit a space bar to do it. In other words, that's a picture you set up special. It's not a regular picture, it's just you go to paint and write these words that you want the person to do, and then you tell them that's what to do. So you go back here, let me go to the very first picture, you'll see what it looks like. See, that's just from paint, that's all that is, nothing else going on there. Okay, now, so what happens is you put that picture in, and that starts off. Now this is the part here that looks really weird. Instead of saying, quote, climb0.jpg, I put that word photos in front of it. Now you may wonder why that is. Here's the reason why. In all of our programs so far, what we've done is every single picture and include file and HTML, all those things are in exactly the same folder. We haven't gone to any other folders. Everything's in one folder. That way, all you have to do is name the thing that you want, and it's in the same folder, so it's fine. But supposing you had a bunch of pictures, like I got 20 pictures here. If I put those 20 pictures in the same folder that my program's in, it's going to mess everything up. There's going to be a bunch of stuff in there, and pretty soon everything's going to get confused with the pictures here and there and all that. So what I said is, why don't I put my pictures in a subfolder? I'll put them in a folder inside that folder, and then they will contain the pictures, and outside of the folder will be like the programs. But in order for the program to know what's inside that subfolder, you have to say the name of it. And the name of that subfolder is, when I created that folder inside there, I called it photos. So in other words, I created a folder inside CS101 called photos. And what that does is, that contains the pictures. And so notice what I've done here. I said, well, down here I said, quote, photos / the first picture. So what it does is it looks inside the subfolder photos, and then it grabs the first picture out of it. That's called a pathway. That's the magic word, is pathway. The pathway is how you get to the stuff that's inside subfolders, okay? In this case, it's only one subfolder. You simply go from the folder you're in to this one inside of it. Sometimes you have to go inside of another one and another one, in which case you have more slashes and more names. But basically what you do is you put the name of the folder here, / the name of the picture. Now, so that's how it starts off, okay? And then I gave that first picture the identification show it. That means that location on the screen is called show it. Now, its ID is show it. If I put anything else and show it, it'll change the picture in that location. So right down here, I've done two things. I put a picture in, and I gave it a location name, show it. So then what happens is, when I hit the space bar, whenever I hit the space bar, what happens is I go to key hit because I hit the space bar, and it comes down here and says, did you hit the space bar? 32 is the number for the space bar. Okay, so if it says yes, I hit 32, then it jumps to this function called change, and it comes down to this function right here, which means change the picture. So it says, okay, index plus equals 1. I'm using index, which I defined up above here as 0. I'm using index to tell me which picture do I have. Which picture am I talking about, okay? So I said, well, if index equals 18, that's the highest number I want to get to, 18. Then what I do is I set index equal to 1. So in other words, if it's 18, don't want that one. That's not a real picture. What I want is picture 1. Now I would have picked picture 0, except for the fact that would give me the original thing that says, okay, now you can hit the space bar. I just want the pictures to recycle now. I don't want them to come back to the original. So I said, okay, when you reach the very last one, if you're at the last one, change the index to 1. And then here's what happens. This line right here is the one that actually puts the image on the screen. It says, okay, show it dot source, and show it is this thing I defined down here. That's the location of the picture. The source, no, so I'm saying now is, what picture do I want to put in there? I put in, quote, photos, which says it's inside this folder, slash, and then I put a quote mark. This is just an expression right here. Quote, photos, slash, unquote. That's an expression. Plus, whatever is in here. Whatever is in here, of course, is pictures index is actually whatever picture is in index. So if index is 1, it's pictures 1. Okay? Now, notice what it does is it says, this is right here, this index right here, it's in this array, and it's in position 1. So it's going to grab this one right here, not that one, because that one is the one that says, hit the space bar. I don't want to hit that again. So it comes back to this one right here, and it puts that one in. That's what index is, that first one, because it's 1, and that's 1. This is 2, this is 3, this is 4, and so forth. So what happens is it puts that one in, and then when I hit the space bar again, it comes in again, it adds 1 to index, so now it's 2, and it says if index equals 18, which it doesn't, it comes down here and it says, okay, show me photos slash index, which is 2. Show me what's in pictures 2, which is up here. Pictures 2 is right here. Gives me that picture. So what it does is it keeps changing. As I hit the space bar, it just keeps going to the next one, the next one, the next one. This thing here doesn't have a loop. It doesn't have a formal loop, but in a sense, it is acting like a loop. I'm just using this as a demonstration of how you do this kind of stuff. And so that actually right there is the whole program. There's not much to it, as you can see. In fact, that's the whole program. You can see it all. There's not much there. This right here is the only function, and it doesn't do very much. But the ideas in this thing that I want you to take away are, first, this index right here is being changed, and the index tells you which picture you got here, 0, 1, 2, whatever. And then when you get to the end of the numbers of pictures you have, you don't want to go outside the range, so what you do is you say, well, if it's 18, we've reached the end, so change the index to 1, and then when it comes down here, it starts off at 1 again, and it restarts the cycle of looking at the pictures. That's one of the things I want to do. And the second one, I want you to realize that this is how you put photos, which is the folder name, together with the name of the picture that you're trying to grab out of this array right here. Notice how you do it. You put quote, photos, unquote, slash, unquote. You gotta put that slash in there. And then, because you want it to look just exactly like that, right there, with photos, slash, name of picture. And that's how it's done. That's actually how the thing works. And that's unusually long, unusually complicated first program for using arrays. But it's easier than what we'll be doing next, so I thought I'd start with that one. And that's it pretty much. So then what you do is you keep hitting that space bar and it keeps going to the next pictures. That's all it does. That one's over. Okay. Let's go to Shroud. 23, here we are. Okay, this program right here is a 3D graphics program. What that is a series of wafers. It's basically what a series of cylinders, one on top of the other. I recreated them over and over and over again. And it looks like some kind of a column of cylinders. That's all it is, really. And so what that is I did that by creating a cylinder, and then another one underneath it, and another one, maybe I did vertically, maybe 1 plus 1 plus 1 plus 1. I just built all these things one at a time. If you look at the code for this thing, not like that. Here. If you look at the code of this thing right here, blow it up a little bit. Right about there. You'll see, as you look at it, that in order to draw each one of those cylinders, I drew the first one, I called it wafer. I drew the first one, then the second one, which is number 1, and then the third one, the fourth one, the fifth one, the sixth one. You see what I had to do? I had to draw each one of these wafers, boop, 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 like that. And each one of them took all these positions and rotation locations. I had to do all that manually, okay? So, the point is, and then down here, what I had to do is, I had to create each one of the wafers one at a time. So I had to create each one of them, give them a name, a distinct name, and I had to create them all. So in other words, what I had to do is a lot of writing to create them, and then a lot of writing to show them, okay? So what I'm going to show you is, the next program, what I do is, I use loops to accomplish the same thing by not having to write all that stuff. So we go to here. Here. Here, I think, yeah. And there it is, that's the same, it looks the same, doesn't it? It looks exactly the same. But when you go to the code, this is what it looks like. This right here is all those things, all those over and over and over again, reduced to just one loop right here. One loop. Okay, I'll talk about it in a second. That's one loop. And then down below here, all those bringing the things in, I only brought them in one loop. So therefore, I cut off all those, having to rewrite those things over and over and over again. Let me tell you how, first of all, how I brought them in. That'll be, it goes from I to 10 because there are 10 of these things, from 0 to 9. So therefore, the I goes from 0 to less than 10, I plus plus. Down here, I called the thing work when I brought it in. I brought a thing in and I called it work. I gave it all the same name. I said, make a cylinder and use this texture on it and call it work. And then what I did is, down below, I said, push work onto this array. You know, the head array up above, which is called wafers, and I push it on there. What I do is I take each picture as it comes in and I push it onto the array. But because I is changing, what happens is, the first time I push it on, it pushes into a certain position. And then when it comes down the next time, it pushes into the next position, and it pushes into the next position. By the way, push does that on its own. You don't have to change I or anything. Every time you say push, it pushes it onto the end of the array, wherever it is. So the I is not related in that part. The I, in this case, the I is only, the only thing the I does in this case is to keep grabbing a new picture, a new cylinder every loop. So every loop it creates a new cylinder, and then I push that cylinder onto wafers. Here's wafers up here. There it is. It's just an empty array. There's nothing in it. So the first one it pushes on is called wafers 0. The second one's called wafers 1, wafers 2, wafers 3, and so forth. Well, I knew I had 10 of them, so I assumed I had 10. So I said, okay, I'm going to make 10 of these things. And then up above here, when I want to draw the things out, I want to draw the pictures out. This 4 next loop right here, that's it. That's where I do. I draw the things out. Now watch what happens. If I had drawn all of them at position 0, Y0, Z0, so forth, all the wafers would have been in the same spot. It would have drawn them all, but they all would have been in the same spot, so I wouldn't be able to see them. So what I wanted to do is, every time I went through this loop, I wanted to push them a little bit someplace. So notice right there, I said Y multiplied by I, 2 by I. Here's what I did. The first one comes in, it's still in position 0 in the X direction. But now, what happens is, this is the 0th one. When you multiply 2 times I, it's still in 0. Therefore, Y is in the 0th position, Z is in the 0th position. So the first wafer is in the 0 position. The second one, because I becomes 1, then what happens is it comes down to here and it says, now the Y position is 2 times 1, which is 2. So it moves the second one up here. And then as it comes through the third time, that becomes 3, so 3 times 1 is 3, so it moves it up, 3 times 2 is 6, moves it up here. So it moves it up. Every new one gets moved up higher and higher. So what's happening here is by going through this thing 10 times, I take the 10 wafers and I bring them up one after the other. And by the way, notice over here I'm using wafers of I. I the first time is 0, so therefore I'm doing what's necessary for the first wafer. When I becomes 1, I'm doing whatever's necessary for the first wafer, and then the second wafer, and the third wafer, and the fourth wafer, as these numbers change. So basically what I'm doing is, this thing right here is allowing me to take these wafers and stack them up just like that, makes them look like that. And it does it the same way as the previous program did, only it does it manually. Let me show you one more like this just to do it. This one here. These yellow cubes, which all they are is the same, they're just a bunch of yellow cubes on the black screen. All I did was draw a bunch of yellow cubes, okay? So if you look into this program, again, it's the same idea now, that's what I want to do it. You look at this one, you see, the same strategy. What I have is, this one here takes 96 lines of code. I wrote that in there because I counted the lines of code, not including the open and shut things. But this got 96 lines of code, and here's why. Because I have to do it for the first cube, the second cube, the third cube, the fourth cube, blah, 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 all the way down. Each cube has to be positioned and brought in there. And then in the bottom, I have to create all the cubes. So I have to create these cubes. So that takes a bunch of lines also, okay? So instead of doing that, I said, okay, let's use the loop to do the same thing. So I went to the loop program, which is down here somewhere. And there's the exact same program. It looks exactly the same. Nothing's different except for the fact that when you write the program, you don't have to write all those lines of code. This one here, the entire thing is done right in that little section right there. Notice everything is accomplished in that section right there. Now in this case, if you saw the cubes were next to each other, this one, this one, this one, this one. I started the first cube at exit minus 60, that's what I did. And then I wanted to move each cube after that 10 to the right. So I added 10 to it. So in other words, when I is 1, I add the next cube is 10 plus minus 60, which comes out to minus 50. And then the next one is 2, so it's 20 added to 60 comes out to minus 40, 50, 40, and then so forth. In other words, every one I add, this thing right here, adds a new position to the x. So each cube that's created is created in a different position in that loop, okay? And that's all there is to it. Down below here, of course, I did the same thing. I just simply pushed onto the work, and I didn't do all the work of bringing in 10 cubes, okay? So that's actually something, these programs are something you can kind of look at to see how the easy-breezy version of these things, how they're done. I brought in this one here with a bunch of toruses. It looks a little weird. Looks very weird. There it is. These are toruses here. And what I did was, all these are just donuts. It's just a torus, that's all. But I took a bunch of them and locked them together, made them look like a chain. Now there's one different thing between this and the previous ones. Again, I can either take each torus and treat it one at a time down in the thing so they'll be in the proper positions, or I can make a loop to do it. The trouble with the loop is that the first one and the second one, you can see they're right angles to each other, and the third one's are right angles to that one. So in other words, what I'm doing is each one is in a new rotation. So I have to somehow I have to introduce that into the loop. I have to say, in this loop, I've got to have the first one upright, the second one flat, the next one upright, the next one flat. I'm moving them just like I did with the cubes, going across and building them, but the trouble is they're in weird positions. So in order to accomplish that, I had to, if I did them individually, it's easy. You just simply say, put this torus here, this torus here, this torus here, this torus here. It's easy to do. But when you're in a loop, and you have to actually make one loop, describe all the toruses, now you have to program, you have a little bit of a program problem. Let's see, this one here is not the one I want, though. I want the next one here. Okay, here it is. Let's look at this program and see how it's done. This one actually does the calculation for you. Okay, so this one, as you would expect, is weird. And here it is right here. This loop goes from right here down to here. It's a long loop. You can see it goes from here to here. It's a long loop. And the reason why is because I have to treat the toruses to turn them sideways. Every other torus has to be sideways. So here's what happens. I say, okay, to minus 60, add 15 each time. So basically it starts out, the first torus is a minus 60, then I move it up 15, then I move it up 15, and whatever, because I keeps changing to 1 to 2 to 3 to 4, so that keeps changing. So the X one is easy. Where the toruses are is easy. It's getting them to twist that's the hard part. So then I come down here, and I have this variable outside of it I call flipper. I set it at 0 to start with. And then while I'm inside the loop here, what I do is I say, if it equals 0, which means it's in the original position, I say if it's equal to 0, then this right here equals x equals 0. It's in the, pardon me a second here. The rotation, it doesn't rotate. It rotates not at all. And then it turns flipper to 1, because the next time through it's going to rotate. And then it says else. What it means is the flipper was 1 to start with, because there only be 2 things. It goes on and says, well, it's going to rotate. So you rotate the thing, then you set it to 0, and then you get out of it. So in other words, each one either comes in as 0, in which case you do nothing, but you set it to 1, so next time it will flip. And if it comes in at 1, you flip it, then you set it to 0, so next time it won't flip. And that's all you do. It's a little bit of a trick you have to do in here. This is not the only way to program this. There's a lot of ways to program stuff like this. But this one is kind of simple. It's kind of an easy idea, is you have one variable out there that tells you is it tipped or not. And you do what you have to do, then you either tip it or untip it after you do that. Okay, so that actually takes care of that. Again, at the bottom, I just use that loop to do this thing here. That's it. Okay. If you have any questions, you guys, any questions about that, tell me. I hope that I'm not going off the screen here. That's all I'm worried about. Okay, at the end here, this right here is a video that describes how we use 3D graphics. Every different course in 3D graphics approaches it differently. This one here is kind of my way of doing it, and it kind of shows you what we need to do to make ours work. And it's pretty straightforward. So if any of the other stuff has gotten lost on you, this thing won't get lost on you here. Let me go back to the first program, which is a bear. I don't even think, I don't know if the microphone works or not. I'll try to see if it does. Banana. Banana? Anybody got a computer here?
Oh, it's.
You should be able to say banana, and that door should open. If I had my own computer set up, it would open. I've got this thing set up so that you can move around inside this. This is the door that we're at, but you can't get in because it won't let you in. It blocks you until you say the magic word. The magic word, by the way, is supposed to be melon. That's the magic word for M-E-L-O-N. I think that's the Elven word for friend. But I tried that, but the program only looks for English words, you see. So we look for M-E-L-L-O-N. What question?
I was going to say that you should spell it M-E-L-O-N, like
M-E-L-L-O-N. If I did that, it would probably do it. I wasn't sure though if that would catch it. You know, sometimes melon, I don't know. I'm not sure it would catch it. So I changed it to banana. It's like melon, banana, what the hell. And so anyway, so if you say banana, those doors will open, and then you can get inside the inner chamber there of Maria, and then the doors will shut by themselves, and the sound effects and all kinds of stuff. But basically, this program has. Oh, I wish I could run this program. I'll tell you what. Let me. We still got time. Let me set up my computer because I want to run this thing, and I think it's worth seeing because you could see where you could easily use a loop to build the structure inside there, which I didn't do. I should have done. I didn't do it. Just go in here. Give me a second to spit it up. let's, it takes a while for these programs online to load because if you use big textures. My advice to you is this. You can use a texture that's like, 128 by 128, or one that's 1024 by 1024, banana. Yes, it worked.
If you don't hurry, the door's gonna close.
What?
If you don't hurry, the door's gonna close.
It even has the columns.
See if I can get in that dumb thing. Come on, get in that door. I have trouble moving here. Okay. Get in there.
Return to the key.
What you really want to do with programs is use the mouse for this navigation. I'm using the keys because that's all we've done so far. The mouse is a little bit tricky. Let me, I think we're
So
okay here.
you shall not pass that move.
After you get inside, you're in. It's got that ominous never open again door. It'll never open again. But once you're in there, you can see that this is nothing here. This is just very simple. But what I've done is I've got a lot of repetition. Look at those columns. And at the foot of the columns, I've got these little pedestals to hold the thing up. And these pedestals actually have to be built one at a time too. So basically what I have to do is I have to column here, column here, column here, column here, column here, column here. Flip, all those things on the bottom. One loop could have done all that stuff, okay? But I didn't. I actually did it manually. If you look at the program, you're going to see it's a manual drag out. Because that was the first one I did, and I hadn't introduced loops, and I said, okay, I'll just do it the easy way, or the visually easy way, but the hard way actually programming-wise, and that's it. By the way, you can't get through the wall when you're coming to it. When you're first coming to the thing, you can't get through. Where am I here? Where's the end of the thing? I'm lost. Loused. There we go. So I can go back through. Once you're inside here, you can get back out. It only locks you out at the beginning. Until you say the magic word, you can't get in. But once you're in, you can go through the walls and everything. And by the way, another thing too, which this program is not that specific. If you say the magic word and the door opens, you also can go right through the walls. It doesn't do. I could have set it up so that only I could say if you're passing through at this point to this point, allow you to go through. Otherwise, don't. It's too much work, too much programming. So I said, okay. I'll just let you, once you say the magic word, the door's open, you can go through the wall or any way you want to go through it, okay? But this is, you can go through the wall now because you've already gone through it, so the signal's been set, you can go through it. And that's pretty much it. That program, the only thing about this program is of interest to us really is the columns, how to reproduce the columns without writing a lot of code. I won't ask you to do that. I thought about asking you to write a program to do that. No, to take this program and change it from its long structure and just make it short so that it would be a shorter program. But then I realized the placing of the columns is so complicated that I didn't want to get you into all that. So it's too late in the semester to get you into that. So that's pretty much it for today. The loops, the array, and the use of those things is what I really wanted to get across, and it's something that I'll repeat in the next class. I'll have some more stuff. We won't be covering this again, but I'll have programs that give you a little more practice with that so you can see what they look like. If you don't forget, if you have any questions ever, don't be afraid to ask them. There are a lot of people online who they watch these videos. I've been watching the count. They're always behind though. They're always behind by a week or two or three or something. Then they start catching up. But they still do watch the videos, and they still depend on you guys asking questions or me talking or whatever to get the information they need. So that's pretty much it. I was going to mention the project is getting into the line now. We're getting pretty close. We're halfway through November, and it's got to be done by the first part of December. So you got a couple weeks. The project doesn't have to be all that complicated, but it has to use some of the things that I listed that you should employ. I had a student, and I'm gonna tell you this out in the open because it happened, I didn't like it. There are people who have taken HTML courses in the past, they take this course, and they think they're just gonna be able to write this, same code that they wrote for their other, that doesn't work, because I'm not teaching HTML, as you well know at this point, and basically, I only want the code that we worked with. I don't want to see any metas or any of these weird things that I use, but I don't use them in this course. I would like to have you not use them, so that to show me that you actually, the information you got was from this course, it wasn't from a previous course in HTML or something. So I'd like everybody, you guys online especially, do not ask someone to write a program for you under any circumstance, because I have the electrodes. Okay, that's it. I'll be here for another half hour if you guys go to do.
So you need help on that canvas?
I need help.
Okay. You need help? Well, I'll turn the camera off,
Yeah.
because I hate to have me yelling at you online like this. It would be embarrassing.